A list of similarity statements, like true-false statements, can be a little overwhelming when you look at it. So I want to go through each one of these things and just sort of break them down according to what they mean and which of the three theorems they're talking about. So this first one right here, similar triangles must have congruent corresponding sides. Well, that's a little bit of a mouthful. What that's basically saying is, I'm sorry, I said sides, but I meant angles. It means same angles, right? It means if these triangles are similar, they have exactly the same angles. Sure, maybe it's rotated around and one triangle's upside down. That's fine. The angles are all still the same. Statement number 2. Similar triangles must have proportional corresponding sides. So, in other words, the sides are in constant ratios. Boy, I hope that clears that up. Maybe it does, maybe it doesn't. But let me draw you an example of what I mean here. We've got this triangle with sides ABC, and that triangle, that's a little special looking triangle there, with sides D, E, F. And I'm telling you these are similar triangles. In other words, believe it or not, they have the same shape. And the way you would express that in similarity would be to say something like this. You would say A over D equals, looks like B over E from it, right? We set up these fractions using the sides in this ratio format or in fraction format. So that's what that means. All right, let's take a look at the next statement. Similar triangles must have the same shape. Well, that's another way of saying same angles again, right? See, some of these things are just repeats of each other, but they're all dancing around this idea of angles have to be the same, sides have to be in ratios. Now, there is one of these statements that is truly different from the others. This fourth one right here. If two angles of a triangle are congruent to two angles of another, no, not that. That's another way of saying same angles. Because if two angles are the same, that means the third one has to be the same because they all add up to 180, right? Okay. I'm sure there's something new in here. Hold on, let's just skip to... Okay, number 5. Number 5, right there. That thing says two equal angles, two proportional sides and one equal angle between those sides. So that could be a little hard to understand. I'm going to draw a picture. We've got a triangle right here. Hopefully I do better this time. A, B, and we'll call this angle C right there. And I have another triangle over here. You can see they're kind of in different arrangements. And this is, we'll call this D, E, and we'll call this angle F, like so. What I'm telling you is that if you can say the following things, A over D equals B over E, there's that side ratio statement. And if you can also say this, angle C equals angle F, now that's a similar set of triangles. So you see, that's a little bit of a mixture of those first two ideas, equal angles and proportional sides. Now this theorem has a little bit of a mix of all of them. So to wrap this up, I want to give you the theorem names that you'll often see associated with these ideas. When you see the same angle thing, that is called the AAA theorem. Sometimes people just call it the AA theorem, that's fine, but it's basically the all angles theorem. When you see this bit about constant side ratios, that's the side theorem, okay? And this one that I just mentioned to you right here, this is the side angle side theorem, okay? And those are all different versions of triangle similarity.